Good morning, all. Now we are discussing the last part of unit number second, that is Laplace equation, that is analysis of a 2D flow, that is it is analytical solution, and second one, that is a flow net, it is a graphical solution. Okay, so in that, first of all, Laplace equation, which is called as a which is applicable for two-dimensional flow. So what is meant by two-dimensional flow? When the flow of the water in x direction as well as in a y direction, which is called as a two-dimensional flow. One-dimensional flow means when the flow of water in a one direction only. Suppose that is in x direction only, which is called as one-dimensional flow. Three-dimensional flow means when the flow of water in a three direction, that is one x direction, y direction, and z direction, which is called as a three-dimensional flow. And what is two-dimensional flow? That is when the flow of water in x direction as well as in a y direction. So while solving this Laplace equation, Laplace is a scientist made some assumptions while solving it. First of all, flow is a two-dimensional, that is flow in a x direction as well as in a y direction. Second one, that is quantity of water entering into the element is equal to quantity of water leaving into the element, यानी कि जितना पानी अंदर जा रहा है उतना ही पानी बाहर जाएगा. Then flow is incompressible. Flow is incompressible. It is not compressible. Then Darcy's law is valid. Okay, we know that Darcy's law, that is velocity directly proportional to unit hydraulic gradient, that is V equal to Ki, and the soil mass is isotropic. Isotropic means properties of material are same in all directions. This is called as isotropic. Means properties are same in all direction. Okay, so while deriving it, so these are 5 assumptions. Okay, so he modeled one soil sample specimen in that. So this Vx and Vz with the velocities in x direction and z direction. So this Vx and this Vz are the velocity in the x direction. These are the inlet component. And corresponding outlet components means यहाँ से flow जा रहा है. So at that time velocity will be Vx, and when it is enter, at that time velocity is Vx, and when it is leave into the element, at that time velocity will be Vx plus dvx, that is delta Vx upon delta x into dx. Similarly, when for the second direction, when the water are enter into the element, at that time velocity will be Vz, and when it is leaving into the element, at that time its velocity will be Vz plus same like that, that is dvz upon dz into dx. Okay, so here is Vz plus dvz upon dz into dz. Okay, and the thickness of the section will be dx and dz. These are the thicknesses dx and dz. Okay, dx and dz. So note that these are the inlet component. Vx and Vi are the inlet component, and that is while entering into the element because the flow is two directional flow. So one direction is Vx and second direction is Vz, and while leaving into the element, that is outlet component, that is Vz plus dvz upon dz, or delta Vz upon delta z into dz, and Vx plus delta Vx upon delta x into dx are the outlet components. Okay, so while solving, we are using all the assumptions that were made by Laplace. The first assumption, so according to his, what are the assumptions? We know that the first assumption is flow is two-dimensional. Second assumption is the quantity of water entering into the element equal to quantity of water leaving into the element. Okay, so according to so now we are using the second assumption, that is quantity of water entering into the element equal to quantity of water leaving into the element. Okay, so the So we know that. So these are phi x, okay. While entering it, it enter into this whole area, that is phi x, and this side is dz, okay. That is phi x. So let we see this diagram, okay. While entering, जब जाएगा ये पूरा के पूरा क्या हो जाएगा, कवर हो जाएगा, that is phi x into dz, that is quantity into dz. And while so this is one direction, and second direction क्या हो जाएगा, phi z into dz into into dx, because it is entering into this whole area, of size dx, because this size is dx, okay. And this size is dz, okay. These are the inlet component, and corresponding outlet component, while leaving it is also leaving into this area, this size and this size is same, this is also dz, and this is also dx. So our inlet component will be phi x into dz and phi z into dx, and our outlet component will be equal to, because what is the assumption, entering into the element, that is equal to leaving into the element. So while leaving into the element, it's leave into this area, means the same formula will be applicable over here. Only what is the formula, that is phi x plus delta vx upon delta x into dx into dz, because this whole component into dz, into this dz, because it's live into that corresponding area. Similarly, this second one, that is phi z plus delta vz upon delta z into dx upon this area, into this area, that is delta x, okay. This so here is that is phi x into delta z into 1, because we know the one dimension delta z, and another dimension we are assuming as a unity, that is 1, that is phi x into delta z into 1 plus phi z into delta x into 1. So these are the inlet component, that is quantity of water entering into the element, equals to quantity of water leaving into element, that is phi x into phi x plus dvx upon dx into delta z into 1, same like that, only that area we have to multiply, plus this is another direction, that is delta vz upon delta z into delta x into 1. So here is delta x into 1, okay. So while solving it, okay, either you are solve this equation, or or by simply cancel all the terms. So it is not actually, it is cancelled, we have to solve it, but many of books they directly written as by solving, okay. So how it is solved, okay, I'm saying a simple way how to solve it, okay. So this is not actually mathematical one, so you have to cancel all the similar terms. So first of all, cancel this vx is equal to term, this vx also get cancelled, then this delta z into 1 is get cancelled, similarly this delta z into 1 is get cancelled, okay. Then this is the delta x, this is delta x is get cancelled, this is delta x get cancelled, okay. And here's some phi z is remaining, while writing is phi z plus delta vz plus delta z. So this term is also get cancelled, okay. Cancel all the similar terms, okay, while solving it. So only remaining part will be delta vx upon delta x plus delta vz upon delta z equal to 0, okay. How to solve it? Either you solve all the equation, but 99% books directly give write down this equation, okay. So how it comes, you have to cancel all these terms. So but note that here is delta z यहाँ पे राइट करने का रहेगा, that is sorry phi z राइट करने का रहेगा, that is this is out this is equation, this is equation. सो दिस इक्वेशन, तो यहाँ पे आपका वी जेड राइट करने का रहेगा, तो वी जेड कैंसिल हो जाएगा ना, बराबर ना. सो वी एक्स कैंसिल हो गया, वी जेड यहाँ पे वी जेड था वो कैंसिल हो गया, डेल्टा एक्स कैंसिल हो गया, डेल्टा जेड वन कैंसिल हो गया. तो खाली बचा क्या आपका डेल्टा वी एक्स अपॉन डेल्टा एक्स प्लस डेल्टा वी जेड अपॉन डेल्टा जेड इक्वल टू 0. ओके, सो आपने अभी एक assumption यूज किया, सेकंड नंबर assumption. So now you're using the fourth number assumption. What is the fourth number assumption? Fourth number assumption is Darcy's law is valid. Okay, क्या बोलता है Darcy's law? Velocity is directly proportional to the unit hydraulic gradient. That is V equal to Ki. According to Darcy's law, V equal to K into I. Okay, so for x direction, what will be the formula? What will be the formula? That is Vx equal to kx into I, and for z direction formula will be phi z equal to kz into I, kz into I. Okay, so we have to put this formula here. So phi x equal to kix and kiz, that is kx into I x, or you can call it as kx into I or kz into I. So so in terms of derivative वो क्या हो जाएगा फिर kx dh by dx and kz dh by dz. ओके, सो अगर वापस इसका डेरिवेटिव लिया आपने और दिस टर्म यहाँ पे पुट कर दिया आपने वी एक्स की, वाह वी एक्स यानी कि क्या है, वी एक्स यानी क्या है, that is kx into dh upon dx, that is kx into dh upon dx, that is kx into d square h upon dx square, because यहाँ पे आपका d square x upon dx square plus kz into d square h upon dz square equal to 0. But according to assumption number 5, soil mass is isotropic in the all direction, means the soil isotropic means soil properties are same in all direction. So we have assumed kx equal to kz equal to k, okay, equal to 1. okay, so आपका फाइनल सॉल्यूशन क्या आ जाएगा फिर, डेल्टा स्क्वायर h अपॉन डेल्टा एक्स स्क्वायर प्लस डेल्टा स्क्वायर h अपॉन डेल्टा z square equal to 0. okay, this is a Laplace equation. Note that this equation is for your online examination. So next is a flow net. okay, so this Laplace equation is an analytical solution, while this flow net is a graphical solution for two-dimensional flow. okay, for 2D flow. okay, when the flow is in two direction, at that time Laplace equation is analytical solution and this flow net is a graphical solution. So what is a flow net? It is a combination of flow lines and equipotential lines, or we can call as this Laplace equation which gives two set of curves, namely equipotential line and flow line. okay, forming a mesh or forming a net which is called as a flow net. okay, so while deriving this analytical solution, we give two equation, we give two set of curves. This is the first one, this is a equipotential line, we can call it as a streamline or a flow line, sorry, it is flow line, and second one are equipotential line, forming a net, this is a net which is called as, so one line is called as equipotential line, and this horizontal line which is called as a flow line. okay, so these equation, so this is, suppose this is a equation of in terms of delta x and this equation of delta z, forming a set of a curve, and forming a net, and this net is called as a flow net. Okay, so it is a combination of flow line and equipotential line forming a mesh called as a flow net. So in an isotropic medium, the continuity equation represent two orthogonal families of the curve. So what is meant by the flow line? What is meant by the streamline? Flow line is also called as streamline, and second one, that is equipotential line. So flow lines is the line along which water particles will travel from upstream side to the downstream side in the permeable soil medium. Okay, so this is a soil sample. Okay, so this is upstream side where water can enter, and this is downstream side. Okay, so it is a line where water can pass from upstream to the डाउनस्ट्रीम साइड. ओके, दिस इज अपस्ट्रीम साइड. डाउन अपस्ट्रीम जहाँ से वाटर जा रहा है, डाउनस्ट्रीम जहाँ से निकल रहा है. ओके, दिस इज वाटर लाइन फ्रॉम विच वाटर पार्टिकल्स आर एंटर एंड लिविंग. That is called as, that is, and next, that is equipotential line. Equipotential line means it is a contour or line joining equal number of potential heads. Okay, you know that contour means क्या है, आपने शुरू में पढ़ा था. Contour means line joining equal number of areas. So here is equipotential. Name indicates line joining equal number of potential heads, which is called as equipotential line. Okay, if we insert piezometer into soil at a different points along the equipotential line, water would rise to the same elevation in all these piezometers. Okay, suppose this is your soil strata, and if you inserted piezometer, okay, so when water is enter into the element, it will rise into this piezometer. This is a glass tube. Okay, so while it is rising into the piezometer, it rises at the same height. So while we drawing this line, this line will called as line joining equal number of potential head or potential rises that can be observed in a piezometer, which is called as the equipotential line. Okay, so next one, that is the flow path or flow channel. Okay, so what is the flow path or a flow channel, and what is meant by the field? Okay, so we know that the flow net is a combination of these flow lines, and these are vertical, these are equipotential line. So flow channel means the it is a space between two flow lines. Okay, this space, because these horizontal are flow lines. Okay, flow channel is the space between, it is a vertical distance between two flow lines. So this distance is called as a flow channel. It looks like a channel. And next one, there is a field. Field is a space between flow lines and equipotential line. Okay, flow lines and equipotential line, space between two adjacent flow line and two equipotential line. यानी कि क्या है, ये flow line है and these are equipotential line. So इसमें इसका जो space रहेगा है, बराबर ना, this space, that is two flow line and two equipotential line. That is this two flow line and two equipotential line forming a square like a shape, that is called as a field. So field is approximately a square. Okay, so next, so if you want to see, so what is the flow line, what are the equipotential lines, so these are clearly shown. These are the flow lines and these are the equipotential line. Okay, so this is a flow channel. So these are the flow channel, because these are all which is shown in a black color. These are the flow lines. And if you and what is the field? Field means this is the distance between these two flow these two equipotential line and these two flow lines, which is called as a field. Okay, so what are the characteristics of the flow line? So note that. So these are very important part. The characteristics of the flow net. I thought you had already learned in fluid mechanics. Okay, what are the characteristics of flow net? So characteristics of flow nets are, these flow lines and equipotential lines are orthogonal or perpendicular to the each other. Note that this is the first one. These are orthogonal or perpendicular to each other, because while drawing we know that these are the flow line and these are the equipotential line are exactly orthogonal or perpendicular, because this is one flow and this is equipotential. So these are equipotential, so these are perpendicular to the each other. Then quantity of a seepage in each flow channel is same. Okay, so what is mean by flow channels? Flow channel means the space between these two flow lines are horizontal. Okay, so while water are entering into this flow channel, okay, the quantity of water will be same quantity of water. ये फ्लो चैनल में जितना पानी जाएगा सेम इतना ये पानी उसके दूसरे चैनल में ही जाएगा. दैट इज कॉल्ड एज क्वांटिटी ऑफ वाटर सीपेज और क्वांटिटी ऑफ discharge is same in each flow channel. Then drop in head between adjacent equipotential lines are same. Okay, so what is the drop in head? Okay, we know that these are the flow lines and these are the equipotential line. Okay, so equipotential line में क्या करते हैं हम? We are inserting some piezometer. Okay, so piezometer में क्या होगा, जब पानी जाएगा तो पानी ऐसे ऊपर चला जाएगा, बराबर ना, पानी विच इज कॉल्ड एज राइज इन ये पीजोमीटर है, यहाँ से पानी जा रहा है तो पानी क्या जाएगा, ऐसे ऊपर चला जाएगा, बराबर ना. सो सपोज देयर आर दिस टू पीजोमीटर, ओके, ऊपर चला जाएगा. लेकिन जब उसमें ड्रॉप हो रहा है, राइज और ड्रॉप, राइज यानी क्या ऊपर चला जाएगा, अगर और नीचे चल रहा है तो जितना ऊपर जाएगा उतना ही नीचे चला जाएगा, जितना नीचे जाएगा दैट इज कॉल्ड एज ड्रॉप, ऊपर जाएगा दैट इज कॉल्ड एज राइज. Okay, so there is a same drop in a head between two equipotential line. So this potential drop that can be calculated by total head loss upon number of fields. Total head loss upon number of fields. Then next important properties or characteristic, there's two flow lines and two equipotential line cannot cross each other. Okay, so this, note that these two flow lines and two equipotential line are cannot each other cross each other, means these flow lines are, it cannot cross, ऐसे cross नहीं होता है these flow lines. Similarly this equipotential line cannot cross, so it not cross to each other. Okay, these are the properties. And next one, field are approximately square. Okay, so this field means the distance between these two flow line and two equipotential line. Okay, if you draw a circle in between that, if it इसमें से अगर हमने वो सर्कल ड्रॉ किया तो it can be easily drawn. Okay, then the smaller the dimension of the field, greater will be the hydraulic gradient and velocity of the fluid. Okay, next one, in a homogeneous soil, every transition in the shape of curve is smooth, being either elliptical or parabolic in a shape. Next one, this flow net does not depend upon permeability of the soil and head causing the flow. And last one, the flow net depends upon boundary condition. So these are not important. So up to these points, these are the important. Okay. So next part is the last part. What are the uses of flow net? Okay, what are the application of the flow net? So there are 4 application of flow net. So you have to just remember the formula. What are the formula were used while calculating these all the applications? Okay, the first one, to compute the seepage quantity or seepage loss. Second one, to compute the seepage pressure. Third one, to calculate the applet pressure, and last one to calculate the exit gradient. So these are the 4 applications. First of all, calculate the discharge. Second one, calculate the seepage pressure. Then calculate the applet pressure, and last one, calculate the exit gradient. Okay, what are the formula that were used? You have to just remember into the mind. So first one, while calculating the discharge application of the flow net, the formula will be Q equal to delta Q, or we can call it delta Q into NF, that is Q equal to KH into Nf upon Nd. Q equal to Kh into Nf upon Nd. Note that this is formula, Kh into Nf upon Nd. So this K means the permeability, H means the head which is causing the flow, Nf means the number of flow channels, and Nd, that is number of potential drop. And this ratio of Nf upon Nd, which is called as the shape factor. Okay, so remember this formula, Q equal to Kh into Nf upon Nd. Okay, अभी कैसे आया है ये आपको नहीं है, तो आप only remember this formula, Q equal to Kh into Nf upon Nd. Okay, next one, to calculate the seepage pressure. Okay, so we know that upward seepage force. So what is the formula for seepage force? हमने पढ़ा था, that is gamma WH into A. And what is the formula for seepage force per unit volume? That is gamma WH into A upon volume. Volume, that is area into L. So A get cancel. बराबर ना? So formula will be gamma W H by L means I. H by L means I. That is hydraulic gradient. Gamma W into I. So this gamma W, that is unit weight of the water. Hi means H upon L. H upon L is a hydraulic gradient. Okay. Then the calculation of the uplift pressure. So this uplift pressure at any depth can be calculated at gamma W into H, where this H equal to H minus N into delta H, that is equal to H minus N into H upon Nd. So N equal to number of potential drop, Nd, that is total number of potential drop, H is called as a head which is causing flow, and gamma W, that is unit weight of the water and the water. Okay, so here we can calculate the uplift pressure. Okay, this is same formula below here. Last one, that is exit gradient. So this exit gradient, that is I E equal to delta H upon delta L. So delta H equal to same is N H upon Nd. So this H is called as the total head. H is called a head which is called causing flow, and Nd, that is total number of potential drop. Okay. Next part is a phreatic line. So this phreatic line, which is also called as a seepage line or top of the flow line, जो top की flow line है, which is called as a phreatic line. Along this phreatic line, pressure head is 0. So note that here only atmospheric pressure exists, and this shape of this phreatic line is a parabolic shape, and the pressure head at the insertion of phreatic lines and equipotential line, at the intersection of a phreatic line and equipotential line is 0. And the next one, the head existing on the top of flow line is a elevation head, that is velocity head neglected, pressure head is 0. According to Bernoulli's theorem, we know that what is the Bernoulli's theorem here, that is क्या था, P by W plus V square upon 2G plus Z. So at the आपको पता है phreatic line क्या है, ये जो फ्लो लाइन है उसमें जो टॉप का फ्लो लाइन है उसे बोलेंगे phreatic line. उसमें खाली कौन सा हेड एग्जिस्ट होता है, which exists only elevation head, that is Z exists at Z. Z means elevation head. P by W means the pressure head. V square by 2G means that is velocity head. So the velocity head and this pressure head are neglected. Only elevation head, that is Z, is exists over there. Okay. So so the Cogeny solution is used to find the seepage through the earthen dams. Okay. Last one, the piping. Last one term is piping. These are the terms. So piping means when the flow occurs at the high hydraulic gradient at their exit space exceeding critical gradient surface, particles are gradually washed away. First of all, fine particles are removed, then gradually a channel or pipe is formed, progressing backward and creating continuous underground tunnel from upstream side to downstream side. So this flow gradually enlarges the tunnel and dislodges even larger particle, leading the even failure of earth structure. This phenomenon which is called as internal erosion. Okay, so this piping which is observed in a dam, इसमें क्या होता है, first of all while piping is observed, first of all some cracks are developed. This is called as the upstream side where the water can be stored, and this is called as the downstream side. Okay, so in that side, first of all what happened, the cracks are developed. While cracks are developed,